and it is given by okay, I have already told you how to find out modulus of elasticity of concrete, and it is given by, write down, given by the clause 6.2.3.1, given by the clause 6.2.3.1, 6.2.3.1, 6.2.3.1, 6.2.3.1, as write down the formula from IS code EC equal to 5000 square root of FCK. Write down the formula EC equal to 5000 square root of FCK, where EC is the modulus of elasticity of concrete in Newton per millimeter square. Write down the formula, where EC is the modulus of elasticity of concrete in Newton per millimeter square. Next, write down Poisson's ratio. Next, write down Poisson's ratio. Okay, so now can anyone tell me what is Poisson's ratio? What is Poisson's ratio? Did you hear the term before? Poisson's ratio? Arif Khan, can you tell me what is Poisson's ratio? Anyone, can you tell me what is Poisson's ratio? If you don't know, just tell me. We don't know, sir. Or if you know, just tell me.
Don't know, sir.
You don't know. Okay, in last semester, did you get this term or not? Last semester or in third semester also, you might get this term.
No, sir.
You have studied shear force and bending moment, is it?
Yes, sir.
You have studied Hooke's law.
Yes, sir.
Then how you don't know about Poisson's ratio? If you know what is stress and strain, if you know Hooke's law, then you must know what is Poisson's ratio, because Poisson's ratio is very much important, and it is very much related to your stress and strain. And this is the thing you have to study in third semester. Okay, so Poisson's ratio, the name itself says it is a ratio. Okay, so Poisson's ratio means it is the ratio between lateral strain by linear strain. I hope all of you have studied about stress and strain. Okay, so Poisson's ratio is the ratio between lateral strain by linear strain. Lateral strain by linear strain. Okay. So now the write down for concrete, it has a value. Okay. Every material has a different value of Poisson's ratio. Okay. So for concrete, write down for concrete, Poisson's ratio value is 0.1 to 0.3. For concrete, Poisson's ratio is 0.1 to 0.3. 0.1 to 0.3. For concrete, Poisson's ratio is 0.1 to 0.6 or 0.3. 0.1 to 0.3. Okay, so next write down number 7. Number 7, write down. You can put a star mark in this. Write down creep. CREEP, creep. CREEP. You can see the chat box also. See the spelling creep. You can put one star mark. Write down. Creep is caused under sustained loading. Is caused under sustained loading. Creep is caused under sustained loading. Write down. Next line, write down. It is seen that comma, when concrete is subjected to it is seen that when concrete is subjected to sustained loading, comma, the strain keeps increasing with time. The strain keeps increasing with time. The strain keeps increasing with time, comma, even without any increase in the load. Even without any increase in the load. Even without any increase in the load. Next, write down. This strain, comma, which is caused due to sustained stress. This strain, which is caused due to sustained stress and which is time dependent, and which is time dependent, and which is time dependent.
Sir, can you please repeat from the strain?
Yeah, this strain, which is caused due to sustained stress, and which is time dependent, is known as creep. Is known as creep. Is known as creep. Okay. So next, write down. You can change the paragraph and write down. You can change the paragraph and write down. Creep depends on the following factors. Creep depends on the following factors. Number one, stress level. Number one, stress level. Number two, age of loading. Age of loading. Number two, age of loading. And number three, duration of loading. And number three, duration of loading. Number three, duration of loading. Number three, duration of loading. Okay, so now I will explain with figure. Then, okay, so now I will share my screen. Okay, share screen. Okay, so can you see my screen? Can you see my screen? Can you see my screen?
Yes, sir.
Okay. Okay, so this is the example I have given in the last class. Okay. So now see the first figure. Okay. Say you have a beam AB. Okay. This is a concrete. It is made up of RCC structure. Okay. It is an RCC structure. Now it is not PCC. It is RCC. Okay. So RCC. Say you have put three loads W1, W2, W3. Okay. So say you have put three loads W1, W2 and W3. Okay. So say 10 years back in 2010 you have put three loads on this beam W1, W2 and W3. Okay, so now after 10 years in 2020, okay, so now it is your 2020. Okay, so now what is the time difference? Now already 10 years. Okay, now it has been already 10 years of putting this load. Then what you will see that the beam will undergo some deformation. Actual beam was like this, straight. When you construct the beam and you don't have any other load, then your beam will be like this. So after the construction in 2010 you have put three loads W1, W2 and W3. Okay, then after 10 years, now at 2000 in 2020 you will see that your beam will deflect little bit, just like your beam will bend like this. Okay, that means you can say why this beam is bent like this, because it has been already 10 years. These three loads are already acting on the beam for continuously for 10 years. For the last 10 years these three loads are continuously acting on the beam, and as a result of that your beam has been deflected like this. Okay, so now in 2030 what you will see, in 2030 after 10 years, in 2030 what you will see that your beam has been deflected more, like this. Your beam will bend more. Your beam will be deflected more. Okay, now what you have understood, that with the increase in with the duration of time, so in this figure it has been 10 years, 10 years. In this figure it has been 20 years. But you, what is the constant thing? This is the constant thing. Your load is constant. The load which is acting on the beam, it is constant. W1, W2 and W3. It is constant. But with the increase in the duration of time, you can see the deflection is more. Your beam is bending more. Okay. You didn't increase the load, but since the time is increasing, after 10 years you will see a small deflection. After 20 years you will see more deflection. Then after 30 years you will see it will be bending more. Then it will be going on increasing. Okay, this deflection will go on increasing, and after 50 years or 60 years you will see some cracks will be developed. Okay, but what is the constant thing here? You are not increasing the load. The load is same, only the time is increasing. Okay, so this continuous strain, why it is okay? So now as you know that strain means what? Strain means what? Deformation. Okay, what is the definition of strain? What is the definition of strain? It is the change in shape to the original shape, is it? Or change in length by original length. Okay, so since the beam has been deflected in this shape after 10 years, that means strain is occurring. After 20 years it is bending more, that means your strain is increasing more. Then after 30 years it will be bending more, that means your strain is keep on increasing with time. And that continuous strain, which is dependent on time as well as the load, is known as your creep. Okay, so in creep you have to remember one thing: your creep is dependent on time and your load must be same. If you keep on increasing the load, that will not be called your creep. Okay, so in creep your load will be same, but it will be changing. Your load will be same, only what will be the difference? The time will be different. Okay, so your creep will be dependent on time, as well as the load must be same on any structure. On this one also, in 2020 also your load is same, in 2030 also your load must be same. Then only whatever strain will be occurred on the structure, then you can say that that is your creep. Okay. Okay, so now can you understand what is creep? Creep is means it is the continuous strain which occurred in any structure under sustained loading. Sustained loading means your load must be same, but only what will happen? It will depend. It is dependent on time. As the time goes on, your strain will be keep on increasing, and that strain will be known as your creep. Okay. I hope all of you have understood this one. Yes or no? If you don't understand, please tell me, or I will go to the next topic. Hello?
Yes, sir.
Can you understand what is script now?
Yes,
Yes,
sir.
sir.
Okay, okay. So next you write down number 8. Number 8 also, it is very important you write down shrinkage. It is known as shrinkage. Shrinkage. Number 8 property, it is known as shrinkage. Okay, so can anyone guess what might be the meaning of shrinkage? Can anyone tell me what is shrinkage? Can you tell me the meaning of the word shrink? If I ask you what is the meaning of the word shrink? S-H-R-I-N-K, shrink. Shrink means, what is the meaning of the word shrink?
Change in size.
Okay, so and one thing, yeah, to become smaller. Okay, contract, cracking. It is not cracking, to contract. Yeah, shrink means to contract, or the size will reduce. Okay, and one thing I want to tell you, those students who join today after say half an hour, from next class I won't let you in. Okay, if you are late by half an hour, I won't let you in. At least in my class, if you are late by 5-10 minutes, then okay, but after half an hour I won't let anyone. Okay, because now also some of the students are joining, so this is the last time I am letting you attend the class. Okay, from next class, if you are late by more than 15 minutes, I won't let you in. Okay, and you will be marked absent. Okay, so please be on time. You might be late for 5-10 minutes, it's okay, but if you want to join after 15 minutes, I won't let you in. Okay, next shrinkage. Okay, next shrinkage, write down. Concrete shows shrinkage, write down. Concrete shows shrinkage due to loss of moisture. Due to loss of moisture content. Due to loss of moisture content. Due to loss of moisture content by evaporation. 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 Next, write down. Shrinkage also causes strain in concrete. Shrinkage also cause strain in concrete. Shrinkage also cause strain in concrete. Okay, next write down. The shrinkage strain, the shrinkage strain mainly depends upon, the shrinkage strain mainly depends upon the amount of water, mainly depends upon the amount of water present at the time of, present at the time of, present at the time of casting, present at the time of casting. The shrinkage strain mainly depends upon the amount of water present at the time of casting. Now, can you understand what is shrinkage? Can you understand what is shrinkage now?
Can you repeat the shrinkage section?
Arif Khan, can you understand what is shrinkage now?
Yes, sir.
Okay, so now if I ask you, I think all of you have seen after casting a slab, while constructing a house, if you are constructing a house, then if you are constructing a RCC house, okay, I'm saying about RCC house. Okay, so if you are constructing a RCC house, then after construction of either beam or column or slab, okay, I think you have seen that we generally put water. We generally put water on that constructed beam or column or slab. What is the reason behind it? What is the reason behind it? Why we need to put water? After casting of say slab or beam or column, why you need to put water? Can you tell me the reason?
Consistency.
No.
So does the
Can you tell me the
casting
reason?
doesn't crack?
Nanu Padung, I can't hear your voice. You speak loudly.
Yes, sir.
हाँ बोलो.
So that the casting doesn't have any cracks.
हाँ what?
So does the casting doesn't have cracks?
Rusting.
No, that casting, that structure.
हाँ.
सर उसको क्यूर करने के लिए पानी डालते हैं,
अरे वो
cracks
curing
नहीं होने
क्यों
के लिए.
करते हैं वो बोलो मुझे. What is the reason behind curing? वो जो पानी डालता है ऊपर उसको हम लोग curing बोलते हैं. Curing of concrete ना. So why curing is done? Curing नहीं करने से
For
क्या?
avoiding,
Yeah, to
sir,
avoid.
for avoiding shrinkage, sir.
Yes, good. To avoid shrinkage. Shrinkage मतलब curing नहीं करने से क्या होगा? If you don't put water, then what will happen? The water which is present in concrete, it will evaporate. Evaporation होने से क्या होगा? Evaporation होने से क्या होगा? If water evaporates from concrete, then what will happen? Some voids will be generated within the concrete. Some voids will be created within the concrete, and because of those voids, your concrete can fail. Okay, or concrete can collapse. So we have to avoid shrinkage. Okay, that's why we have to put water. Okay, we have to put water so that the surface of the concrete must be moist. Okay, पानी से curing करते हैं हम लोग because we have to avoid shrinkage. That means we have to stop the evaporation. We have to stop the evaporation of water from the concrete. Okay, so if I ask you what is the reason behind curing, your answer will be to avoid shrinkage. Okay, to avoid shrinkage or to avoid the loss of moisture from concrete. Okay, strong बनाने के लिए तो वो बाद में होगा. Strong कैसे होगा? If you can avoid that evaporation of water, your concrete will become strong. Okay, to make it stronger is not the answer. Your answer will be to stop the evaporation, of water from the concrete, or to stop the shrinkage of concrete. That will be your answer. Okay, what is the reason behind curing, or what is the reason behind putting water after casting? Your answer will be to reduce to stop the evaporation of water from concrete, or to stop the shrinkage of concrete. That will be your answer. Okay, so now these are the different, okay, so these are the various properties of concrete. Okay, so I hope all of you have understood every property. Okay, so next we have to see what are the types of loads on RCC structures. Okay, so write down types of loads on RCC structures. Types of loads on RCC structures. Okay, so can you tell me what are the different types of loads that will act on a RCC structure? Can you tell me?
Live load,
Yes, and
live load,
okay, or
dead load,
okay, next, or live load, dead load, and
seismic load,
yes, or क्या है? और भी है तो हाँ लाइव लोड नहीं, हाँ लाइव लोड LIVE नहीं, LIVE लाइव लोड, डेड लोड, यस, विंड लोड, हाँ wind
Wind
load,
load.
earthquake load, and last one is snow load. Okay, so snow load कहाँ पे कंसिडर करना होगा? जहाँ पे क्या होता है, कहाँ पे कंसिडर करना होगा बोलो तो? स्नो, अगर आसाम में कोई बिल्डिंग बना रहा है या फिर अरुणाचल में, इफ यू आर कंस्ट्रक्टिंग अ बिल्डिंग इन असम और अरुणाचल, देन डू वी नीड टू कंसिडर स्नो लोड? लिखा है ना, बोलो.
no sir,
नो, कहाँ पे कंसिडर करना होगा तब बोलो?
sir Antarctica,
एंटार्क्टिका है, बहुत दूर चला गया तुम, पास में बोलो.
sir जहाँ
इंडिया,
बर्फ होता है, स्नो
हाँ
गिरता है
बर्फ
सर.
गिरता है. तवांग में अगर बिल्डिंग बनाता है तो करना होगा कि नहीं बोलो?
हाँ सर,
हाँ करना होगा. हिमाचल प्रदेश में, इफ यू आर कंस्ट्रक्टिंग ए बिल्डिंग इन हिमाचल प्रदेश, देन
yes sir,
yes, means in the snowy region where snowfall occurs. So in that case, in those regions, if you are constructing a building or any structure, then you have to consider this snow load. But for all the other regions, at these four loads you have to consider: live load, dead load, earthquake load, and wind load. These four loads you have to consider, and that snow load is conditional. Okay, based on the what to say, site, based on the site or based on the place, you have to consider that snow load. But the other four loads you have to consider for every structure. Okay, so I am not going to give you the definition what is dead load, what is live load. Okay, I will give you only the design code. For dead load के लिए कौन सा डिजाइन कोड यूज करना होगा, फॉर लाइव लोड के लिए कौन सा डिजाइन लोड बुक फॉलो करना होगा, वो मैं दे दूंगा तुम लोग. ओके, सो राइट डाउन लाइव लोड, नहीं पहले लिखो डेड लोड. डेड लोड. ओके, सो कैन यू टेल मी व्हाट इज डेड लोड? डेड लोड मतलब क्या है?
load,
Load of the
जो
structure.
चल नहीं पाता सर.
हाँ हाँ,
Sir, load of the structure.
यस, लोड ऑफ द स्ट्रक्चर बोलने से नहीं, सेल्फ वेट ऑफ द स्ट्रक्चर, खुद का जो वेट होता है, दैट इज योर डेड लोड. ओके, सेल्फ वेट,
yes sir,
सेल्फ वेट ऑफ द स्ट्रक्चर. ओके और ये डेड लोड परमानेंट होता है या फिर टेम्पोररी होता है वो बोलो.
कोई कोई परमानेंट होते हैं सर और कोई कोई टेम्पोररी होते हैं.
डेड लोड
That is
इट इज परमानेंट. डेड लोड इज कभी टेम्पोररी नहीं होगा. डेड लोड मीन्स इट मस्ट बी परमानेंट. ओके डेड लोड इज परमानेंट एंड डेड लोड इज नथिंग बट द सेल्फ वेट ऑफ द स्ट्रक्चर. खुद का जो वेट होगा दैट इज नोन एज द डेड लोड. ओके सो डेड
ओके सर.
लोड तुम लोगों को जो आईएस कोड फॉलो करना होगा वो लिखो. द डेड लोड मे बी कैलकुलेटेड ऑन द बेसिस ऑफ the dead load may be calculated on the basis of unit weights on the basis of unit weights of materials. Dead load may be calculated on the basis of unit weight of materials given in IS 875 you can see the chat box. Okay, IS 875 part 1. Okay, so IS 875 means it is a design code book. Okay, so according to this book, in part 1 everything about dead loads are given. Okay, so when we have to calculate the dead load of various materials, then we have to follow this IS code, IS 875 part 1. Then write down live load. Live load or imposed load. Live load or imposed load. Live load is also called imposed load. See the chat box. Live load is also called imposed load. Live load or imposed load. Okay, so live load मतलब क्या है? Live load. What is live load? हाँ बोलो. लिखा नहीं है बोलो.
तो लोड मूवमेंट में होता है.
किसका होता है?
जिसका सर लोड विथ मूवमेंट सर मूवमेंट के साथ लोड होता है.
जो अभी हम लोग अगर तुम जो घर में है तुम्हारा जो वेट होगा वो क्या होगा? लाइव लोड होगा या डेड लोड होगा?
लाइव लोड सर.
हाँ लाइव लोड. लाइव लोड का और एक एग्जांपल दो तो.
सर चेयर.
Yeah, chair, furniture means, huh? Furniture, those loads which can be moved. Okay, those are live loads. Okay, so next write down live. Okay, so write down live load coming on the structure. Yeah, temporary load on structure. Yes, live load matlab temporary load. Okay, so write down live load coming on the structure. Live load coming on the structure are given in IS 875 part 2. IS 875 part 2. Live load coming on the structure are given in IS 875 part 2. Next write down number 3, wind load. Wind load. Write down the method of calculating wind load. The method of calculating wind load of structure. The method of calculating wind load on structure are given in the method of calculating wind load on structure is given in IS 875 part 3. IS 875 part 3. Next, number 4, snow loads. Number 4, snow loads. Number 4, snow loads. Number 4, snow loads. Okay, write down IS 875 part 4. IS 875 part 4 deals with snow load deals with snow load. Okay, so now can you tell me in which portion this snow load will act? Say say you are constructing a house in Tawang or Himachal Pradesh, so you have to consider this snow load. So can you tell me in which portion of the building this snow load will act? Will it act on the foundation or will it act on the column? In which portion? The foundation or will it act on the column? In which portion?
Roof.
What?
Just rooftop.
Yes, good. Roof. It will act on the roof. Okay, so write down IS part 4 deals with snow load on roofs. On roofs of the structure. IS 875 part 4 deals with snow load on roofs of the building. On roofs of the building. And number 5. Which load is left? Number 5. Number 5 will be which load?
Earthquake load.
Yes, write down earthquake load. Number 5, earthquake load. Okay, so CR, you tell this Chanhun Lalu. Okay, he can't join now. He is trying to join. Okay, he can't join today. It's too late. Okay, so now write down. The earthquake forces shall be calculated. Write down. The earthquake forces shall be calculated. The earthquake forces shall be calculated as per IS 1893. As per IS 1893. You can see the chat box. I have written down the code book IS 1893. Okay, so different design books are there for different kind of loads. For dead load, IS 875 part 1. For live load, IS 875 part 2. Then for wind load part 3, snow load part 4, and for earthquake load, it is IS 1893. Okay, so if you want to calculate dead load, you have to use or you have to refer that first book IS 875 part 1.
अबे बोल
Huh? Hello? Okay, so if you want to calculate earthquake force, then you have to refer this IS code 1893. If you want to calculate snow load, then you have to refer IS 875 part 4. Okay, so this way you have to take reference of different books. These are the design books. Okay, design books. That means guidelines are there with how much load you have to consider, in which condition, how much will be the load. These things are written in those codes. Okay. Okay, so now you do one thing. All of you, please write your name as well as enrollment number in the chat box. Okay, and from the next class, when you join the meeting, when you join my class, just like some of the students, you write down your name as well as your last 3 digits of your enrollment number. Say Arif Khan has written Arif Khan 061. Okay, just like that you can write down this Beki Tayu 053, like that. You write along with the name, you can write down your enrollment number. Okay, so that you don't need to write down this name and enrollment number again in the chat box. $92.
You. Can we leave the meeting?
Hello.
Sir, can we leave?
Yeah, in 5 minutes our meeting will end. Okay, so now just I will tell you, means I will respond. I will tell you those are absent. Okay, I will tell you the enrollment numbers which are absent today. Roll number 69, enrollment number 69, then 52, 54, 55, then 56, 57, 56, 57, 58. All are absent. Then then enrollment number 60. Enrollment number 60 absent. Then roll number 62. 62 absent. 62